The last form of quadratic functions that we're going to look at is called standard form. And standard form has some uses. The last form of quadratic functions that we're going to talk about is called standard form. And the graph of this function, and this is standard form right here, and you know it's standard form because you have an x squared, an x, and a term with no x at all. And it is a parabola that has a line of symmetry or axis of symmetry at x equals negative b over 2a. Okay. So you can look at the function and plug in the values negative b over 2a. The vertex has an x coordinate of the same thing, negative b over 2a, because we know that the axis of symmetry is the same thing as the x coordinate of the vertex, and then that allows you to get the y coordinate of the vertex. Y-intercept is just this value right here, that c value, 0, c. And if you think about it, that should make sense. If you plug in 0 for x, this part becomes 0, and this part becomes 0, and you're left with just that c value. And just like our other forms, we open up if a is greater than 0 or positive, and we open down if a is less than 0 or negative. And we're also going to talk about how some quadratic functions can be written in standard form, but that's also their vertex form as well. And that means you have some options with how you deal with those. All right, so like before, I have the steps up here in case you forget, but we're just going to go down here and start with the examples, and I'll refer to these steps as I do them. So the first thing I like to do is find our axis of symmetry. Remember, the axis of symmetry is x equals negative b over 2a. And here's our a value. You know it's your a value because it's paired with the x squared. It's not a because it's first. It's our 2 is our a value because it is paired with the x squared. Our b value is always the number that is paired with x to x to the first power. So that 6 is our b value, and then 3 is c. All right, so then negative b, so negative 6 over 2 times a, which is 2, which is negative 6 over 4, and that simplifies to negative 3 over 2. So that is our axis of symmetry, and I'm going to plot that over here. So it's about here at negative 1.5. And then I'm going to take this and plug it into our original equation. To get the y value. So 2 in the parentheses, negative 3 over 2, close parentheses, squared, plus 6, parentheses, negative 3 over 2, close parentheses, plus 3. So you get negative 1.5. So negative 1.5 was the x value, and negative 1.5 was also the y value. Okay, so then over here, negative 1.5 comma negative 1.5. So here is my vertex. And then find and plot 2 points. Well, what we're going to do is we're going to use that y-intercept. The y-intercept is 0, c, but our c value is 3. So 0, 3. That's going to be our point right here. And our other point, we're going to reflect this over the axis of symmetry. So we're 1.5 units away. So let's go 1.5 units away on the other side, 1.5. And you see that, oops, our 2 points here are the same distance away from the axis of symmetry. And then we can graph it like this. Now, you could find another point and reflect it, but for us, for right now, we can just do that because I know there's a lot of new things in here. So we're going to leave our graph like that. Now we can do domain, range, and end behavior. Domain by now, hopefully you know it's always -infinity, infinity. Range, we're open upwards. So the y-coordinate of our vertex is our smallest value, and the largest y value goes all the way to infinity. End behavior, as x approaches -infinity, that's the left side. The left side goes up. And as x approaches positive infinity, the other side goes up as well. So the table is here in case you needed it, but I'm showing you that you may not necessarily need it, but it's also there to help you organize your information. Over here, we'll do the same thing. We'll try this one together. So let's do our ABCs. Our A is going to be -1 because we have a negative in front. And again, we know our A is -1 because that's the number with x squared. Your B value is -4. And C is 2. C is always a number that has no x with it. X is symmetry. X equals -b over 2a. I always like to write down the formulas when I use them. That way I am more likely to memorize it when I need to. So negative -4 over 2 times a, which is -1. So there's a lot of negatives going on here. The formula has a negative in it. That's where this one came from. B was -4, and A was -1. So now let's simplify all this junk. -4 gives us 4 over -2, which equals -2. So that means the x-coordinate of our vertex is -2. We'll go over to our graph. Here's -2. And now we need to plug in -2 into the calculator or into the function to get our answer, or to get our y value. Now, please pay attention to how I'm typing this into the calculator. We have a -x, so negative. Now, x is -2, so I'm going to put -2 in parentheses, squared. Again, those negative signs can give you the completely wrong answer. So that, again, that negative in front of x is there. And then x is -2, so I put -2 in parentheses. Then we have minus 4x. X, again, is -2. Let me put that in parentheses. Plus 2. Your calculator is only as smart as the user. The calculator will do the order of operations exactly as you type it. It can't read your mind. So that's why you need to be very careful and use parentheses. All right, we got 6. So we have -2, 6. 1, 2, 3, 4, 5, 6. Our y-intercept is 0, c. So in this case, 0, 2. And then we're going to reflect that over. So we go left 2, we hit the axis symmetry. Go left 2 more. And here's our parabola. Domain, range, our graph is opening downwards, so our smallest y value will be negative infinity, and then all the way up to the y-coordinate of our vertex, which was 6. End behavior, both sides are going down. So as x approaches negative infinity, y approaches negative infinity, and as x approaches infinity, y approaches negative infinity as well. And this one's asking us to compare, that is the RST. We do have a reflection over the x-axis. We also have a vertical, I don't remember what the equation was. We have a vertical, we don't have a vertical stretch at all. I'm sorry, so none. Translation. Well, our vertex was negative 2 comma 6, so that means we were shifted left 2 and up 6. So we don't need vertex form to get our comparison. We can look at the a value. A was negative 1, and the vertex will tell you how this was shifted. All right, now this problem, it says find the vertex without graphing. Describe in words or show algebraically how you found the vertex. Well, what form is this? We see 2x squared minus 5. There we have our a value, which is 2. We don't have a b value because there's no x to the first power, but we have a c value. Okay, so you could do negative b over 2a, but we don't have a b value. B is equal to 0. So that means our axis symmetry would be negative 0 over 2 times 2, or 0. And when we plug that back in to the original equation, y equals 2 times 0 squared minus 5, well, y equals 0 minus 5, which is negative 5. So then our vertex would be 0 comma negative 5. Okay, so that was one way to find the vertex. We said that this was in standard form because we didn't see any parentheses. That's usually a good indicator. But let's see if there's another way to get our vertex that might be a little bit easier. We remember from vertex form that we have a, h, and k. Well, what would this look like if your h value was 0? If h was equal to 0, then this would be y equals a times x minus 0 squared plus k. Well, like we talked about with intercept form, when you subtract 0, you don't need to write minus 0. It just goes away. So then you could think of this as a times x squared plus k. Because once we get rid of the minus 0, we don't need those parentheses. Well, now this right here looks like that. Your a value is 2. Our c value is negative 5. So you could have said, well, this is also vertex form, where the x-coordinate was 0 and the y-coordinate was negative 5. So this example right here is one where you could say it's written in standard form and vertex form, and depending on which one you see is what you could use. If you didn't realize that this was in vertex form, then you saw that I was able to still find the vertex using negative b over 2a. If you realize that, hey, I have an h value of 0 and my k value is -5, then you could have gotten the vertex just from looking at it. So there's more than one way to do some of these problems, and there's no right or wrong way. All right, let's look at the next page where we're going to calculate the minimum and maximum values without graphing, just finding those values. And probably the easiest way to do it is to find the vertex. So I'm going to have you do these top two, this example 2 and the solo. So go ahead, pause the video, and find the minimum or maximum values of these. All right, so these are the answers for those. So quickly double check yours. This was the axis to symmetry, or the x value of the vertex for each of these problems, and then I plugged those in with my calculator to get the y value, which was a minimum or maximum value. Remember, when a is negative, you're going to have a max value, and when a is positive, you will have a minimum value. Now let's look at these down below. We're going to determine if these have a minimum or maximum value, then determine that value. Well, these are the different types of functions that we've seen. Letter A over here is in vertex form. Your vertex here is -7, 3. So we know that 3 value is either the minimum or maximum, and because A is negative, it is a max. So max of 3. Letter B is an intercept form. Okay, this right here gives us an intercept of 0, 0. X plus 12 means we have one at -12, 0. So the x coordinate of our vertex is going to be halfway in between. So x equals -6. Then we're going to plug in -6 for x. And that will give us, I should put this in parentheses so we know it's multiplied. This will give us the y coordinate of the vertex, and that will be our minimum or maximum value. So we're going to get -18. That means our max value, our min or max, in this case is a minimum because our a value is positive, of -18. Letter C, this one is in standard form. We just don't have a C term out here, but we have an A and a B. So in order for this to work, we're going to have to use the -b over 2a. So -b, which is -12, over 2 times -3 over 4. Okay, so the first thing that I will do is I will cancel out the negatives on the top and multiply these fractions down here. And that's going to give us -6 over 4. Now, you could multiply by the reciprocal, or you can type this in the calculator. I'm going to do multiplying by the reciprocal because it's going to help us later on. So this is really going to be 12 times 4 over 6. 4 over -6. Okay, I've multiplied by this fraction flipped. 12 times 4 is 48 over -6. And that is going to give us -8. So -8 is the x coordinate of the vertex. So then I will take that and plug this in. And I'm going to use my calculator that is off screen. And when I do that, I get 48. Since our a value is negative, that means we have a max value. So we're going to have a max of 48. Now down here, we need to convert between the two between certain forms, standard form and vertex form or intercept form. We're going to be able to go back and forth. So we're going to convert from intercept form to standard form, and that means we need to multiply this out. I'm going to leave the 3 alone for now, and I'm going to FOIL this right here, this part and this part. So I'm going to multiply the first x times x, that gives you x squared. X times -5 gives you -5x. Different color. 2 times x is 2x, and 2 times -5 is -10. And then I'll combine like terms, x squared minus 3x minus 10, because I combined these right here. I have to then deal with that 3 in front. And I have to multiply everything by 3. And that's going to give us 3x squared minus 9x minus 90. And now this is in standard form. Over here, there is a trap that a lot of students fall into. You do not distribute this square to both things. You don't say x squared plus 2 squared or x squared plus 4. What x plus 2 squared means is that it's x plus 2 times x plus 2. Like if I had 7 squared, that is 7 times 7. So when I have x plus 2 squared, that is really x plus 2 times x plus 2. And you would multiply it the same way we did the previous problem. So we get x squared plus 2x, plus 2x plus 4. Combine our like terms, x squared plus 4x plus 4, and we still have that -5 out in front and that plus 8 at the end right here. So then we have -5x squared minus 20x, because again we're distributing this, minus 20 plus 8. And that will finally simplify down to -5x squared minus 20x minus 12. And there is our final answer in standard form. So please do not fall in the trap of distributing this. That will give you the completely wrong answer. So I want you to pause the video again to try these 2 problems. Once you are done, you can unpause it to check your answer. If you get stuck, look at the problems right above. It's the same process. Okay, you can look at your answers and check them and see if we got the same thing. You hopefully didn't have any trouble doing 1/2 minus 2 to get -1.5, or you could have done -3/2. It would have given you the same answer. So again, I know there was a lot in this video, so if you need to go back and review something, feel free to. But now we've talked about all the forms of a quadratic, and we can now utilize them and see which one we like better and which one is more useful. So thanks for watching. Make sure to like the video and subscribe.